Okay.
Especially kind of before we start. We try to police ourselves and over, at Brandon's. And, you don't have to like us, but you got to admit we keep each other fairly honest. You got to admit that, man. I want to start just before we really get started. I wanted to help you police your side, something y'all bypassed. If you could be so kind to pull up that indoor rainbow.
The indoor rainbow.
Yeah, man. If you could pull that up, man. I just wanted to point out
all right, hold on a second. Let me grab my reference to that. The one in the garage?
Yeah, the one with the kid in it?
Yeah.
Yeah.
Yeah, that's the one.
That this disgusting Latter-day Saints could not get out of his head. I mean,
yeah, that made my blood boil.
If you watch that, I'm not going to repeat what he said, but if you watch that, how sick does somebody have to be that that's the only thing he can think of when he sees a kid?
Mm-hmm.
Wow, what an horrible
sick
person.
Son of a bee.
All right, I'm looking for it. Coming up here. I store my stuff in Evernote, and Evernote updated their app, and it's super slow. I'm like, I want to not upgrade the app because it's just like they made all these UI improvements, and now it's super chuggy. So rainbows. Here it is, indoor rainbow.
Yeah, I wanted to point out, if you could just play that, and then when it shows the outside window, you could slow it down. I'm going to see if you notice the problem. And then when they show the garage door, when it shows it from the ground up, you might be looking at the kid and everything, but, we like to analyze everything. When you see the garage door for the first time, if you could just pay attention to that spot. See if you see anything wrong.
I'll share.
I'm going to give you a chance to pick it out, and then I'll intervene if you don't find it.
I'll share it to you so you see. All right. So there it is. It's showing.
Yeah, now go ahead and play from that point.
Okay.
Okay.
Yep, so light coming from there.
Okay. Now you see right there and right there. Tell me if you see right there. You see anything wrong right there?
I don't see anything wrong. I see a window, but there's nothing wrong with that.
Well, is the window the white or the yellow?
I think the yellow is down on the bottom there is the window. Right?
Okay, what is the white? Is the white not the window there?
The white bar across the top?
No, the white at the very bottom.
Oh.
The white square window.
That's the window, yeah.
Okay, and then right above that would be the rectangular what?
The rectangular what? It looks like it's the silver reflective coating on the insulation on the ceiling of the garage. I have the same.
The what coating? What coating was that?
The silver reflective coating on the ceiling of the garage there.
Okay, good. All right, good. You caught it. Okay, so that was the whole argument, is that you need a reflection. Okay, if the reason you can't do it indoors, unless you have a reflective surface. Okay, the point is you need the reflector to go with the
that's the new claim, the goalpost shifting change. Used to be that you need the dome. You need a curved surface. It needed to be the dome. The curved dome is what you needed, but now that's changed. Now you just need any reflective surface. Is that now the new way that the rainbows work? It has nothing to do with
a little bit of reflective surface is going to cause that rainbow.
I know, it's so funny.
No, the whole point is that you have to have a reflective surface. Okay?
No, a curved reflective surface.
That was his argument, and
was
he didn't
the original.
catch it.
Yeah, the original was. But now here's the problem. I'll show you that right here. All right. So the way that rainbows work is and you see this in the sky too. When you look towards the rainbow, the sun is behind you. Okay? That's That's where it is. It's behind you. You don't look towards the sun and then the rainbow is over the sun. It's the other direction. And this is well understood, and the mechanism by which it works is well understood. It is it's all based on Snell's law, and it's this.
Well, for anybody honest out there,
Hold on, I'm not done. I'm not done.
Except they can't make one. They sit there and say it's reflecting off the raindrops. I understand what the claim is. It just can't be reproduced indoors without a reflector. That was my whole point in this.
Snell's law.
No, I'm for the audience. For the audience, I'm explaining it. Okay.
Good.
The droplets in the air, the water, the light enters the droplet, and because it enters the droplet at a slight angle, it refracts it, and it separates the light into different colors, right? Because the different frequencies of light are refracted slightly differently based on the frequency.
We agree.
Okay.
We do agree with that.
Then it hits inside the droplet, and it bounces because the angle is shallow enough. Then it bounces inside, and then it comes back out of that raindrop, and it has both reflected inside back towards you, so you look away from the sun, and that's why the rainbow comes towards you, and it has refracted the different wavelengths a different amount, and it's the droplets of water, not a dome, and not a firmament, and it has nothing to do with any of those types of things.
That is great, brother. That is awesome. I just wanted to make sure you knew that there had to be a reflective surface. Now that we've got that cleared up, then you
Wait,
know
did you hear nothing he just said?
indoors, then there's no problem at all.
So
Wait, Brian, let me ask you a question.
Okay, so
Brian, let me ask you a quick question.
Let me hold on, dude. I'm talking to Michael. Let me ask: Are we under the impression that we don't need a reflective surface?
No, you don't.
You need the raindrops.
Okay.
You don't need
What does
anything
Michael
else.
say? Not you. Okay, so you're under the impression you don't need a reflective surface. Okay, science.
No,
okay.
No,
to
wait.
get a prism.
Hold on. Don't
You need two
don't misquote
reflectors.
me.
You need a second. You need a first order. I just listen. Everything you said, you can't give me 10 seconds. Okay, science says you need a second. You need a first order and a second order. Okay, you need the first order of the raindrops and the bouncing around of the light, the refraction of the light, and then you need the reflective surface. Okay, I'm not saying it necessarily has to be a dome. Okay, but you need two orders of. Our whole argument is you need a reflective surface along with the raindrops and the drops, whatever you want to call them, droplets, ice, anything in the air that's reflecting off each other. But you need a second order for a rainbow. That's the whole point. As long as you acknowledge that, I'm good, man.
But
Right, let me ask you this.
Go ahead.
Can you only see a rainbow on a clear day? Or can you see one in a cloudy day as well?
First, are you denying you need two orders of reflections?
Yes.
Okay. All right. Well, then you're a science denier.
No. Can you only see a rainbow on a
Show
clear
me
day?
an indoor rainbow without a reflective surface. The whole rainbow indoors is the lack of reflection. If you have a
So you don't understand how
reflective
reflectors work.
surface,
Brilliant.
then no problem.
Yeah, the two bounces inside the raindrop are the two reflections. You don't need an additional external surface to that. There's no
Can you demonstrate
explanation.
that? Can you demonstrate that?
Yeah. So your claim, the claim that I hear most of the time, and I don't know if this is yours or not, is that somehow it's the dome is involved, the firmament is somehow involved. But I can bring up the actual descriptions of how, if you want, how the reflections inside the raindrop work.
I mean, I don't really want the rhetoric. I want a demonstration of a rainbow indoors without a reflective surface.
Yeah, that's what we're looking at right now. That's what's on the screen right now. So that
You're not showing me a rainbow without a. You're showing me a rainbow with a reflective surface.
That reflective surface could not possibly be involved in this rainbow.
Then it should be no problem for you to show me one without it.
Then it should be no problem for you to show it, right? The burden
I've
is on
tried
you.
it 100 times, buddy.
No, you haven't.
Yeah, maybe not 100 times. Okay, in all honesty, I've tried it 10 times.
So here's the deal.
You want me to turn you? Hey, listen, I'm not a talker. I'm a doer.
How does a grown ass man know how a
right
rainbow
now,
works?
water hose. If you'd like, I'll show you on screen a water hose spraying indoors without a reflective surface, not making a rainbow. But I think we both know better.
A water hose.
Listen, man, you don't gotta always be right, MCToon.
Explain.
Nobody's perfect. Just say, okay.
But on this one,
there is a reflective surface.
But I'll tell you, Brian, on this one,
look into it.
On this one, yeah, it's not that complicated, and there is a good description in physics and a good understanding of this. In fact, there are a few studies where people have done indoor studies on rainbows. Let's see, do I have it?
Yeah, show me a single order rainbow. Show me a first order rainbow. That's all I'm asking for.
What do you mean a first order rainbow?
I mean one reflector. Okay. Yeah. Show me a prism. Okay, with just one piece of glass, just basically not a prism. Okay, you can't just you gotta have, it's gotta be a reflection, multiple reflections to get the rainbow. Second order, at least.
Have you seen the cover of Pink Floyd's album Dark Side of the Moon?
Right, that's a pyramid. It's not just going through one pane of glass, Michael.
Yeah, you said reflections. Those are not reflections. Those are refractions.
Sorry, let me clarify. Okay. You can't just go through one piece of. I mean, you can get a piece of glass and get some spray and get a reflection off the glass, and off of the mist. That would be 2 bounces. I mean, the whole point is
it's not you say
you're
bounce.
Not going to be able to demonstrate.
You say bounce, but do you mean
straight?
Not bounce?
Rain reflective. I'm not really using that as evidence of a dome there. I mean, it could be. I mean, I got to open mine, so maybe, but I'm not going to make that definite claim. That's a huge leap.
It certainly is. It violates so much physics.
I'm having a hard time trying to figure out how a grown man has no idea how a rainbow works.
Yeah.
Okay, well, listen, man, if you want to make fun of me, that's fine, but I would really appreciate you back that up and show me a rainbow with only one, with just a water spray. With
you could just go outside and do it yourself, though. Like, how is it hard?
Michael's not making fun of me.
You can do it on your own outside.
Show me, bud.
You can do it on your own inside. It's not hard.
That's funny, bud. How many times have you tried it? Be honest.
I've done it many times.
You're a lying sack of shit, dude.
Oh, I'm lying. Okay, buddy.
I've tried it right now. I'll show you my setup, dude. It doesn't work.
Show it.
Oh, my God.
Waiting.
One thing we know for sure about flat earthers is the experiment. The attention to detail is always a problem.
Mm-hmm.
Let's see here. So there you go. There is how the water droplet makes a rainbow.
Hey, dude, doesn't work much in the day, okay?
It doesn't work much in the day.
What?
Can you see me?
Do you think that's English?
I said it doesn't work. It doesn't work without sunlight. If it's not daytime, it's not going to work. But
well, it works with. It works. It does depend on the quality of your light bulb. If you have an LED bulb, it can only show you the colors that are present.
Look, I'm under the impression he's showing me. I got my setup with the water spray and the light under the tent where I did the setup. I'm under the impression he's showing me the whole time. That guy claimed that he's done it several times, and he ain't done that. Or else he'd know you can't do it without a reflector. Tried it several times, and I'm showing him right now. And well, I thought I was showing everybody, but you'll see a glimpse of it.
In the bulb. Are you still there, Brian?
No, I'd appreciate if he showed me his setup.
I don't think he has a setup. He just.
I know he don't have a setup. He's lying sack of shit, dude. I prefer to just talk to you.
So, is it only sunlight now? And Are you in a tent?
Yeah, it's a tent. Exactly. Good eye.
Why do you have a tent?
Because that's where I put my little setup.
In your garage?
No, it's outside of the garage.
Oh.
It's in a tent. It's blocking all the sunlight. Anyway, the point is, man, just humble yourself, man, and say you have to have a reflective surface.
Except
Well,
you don't.
I'm showing it on screen. You do need a
Just humble
reflective
yourself
surface.
one time. Show me you're a humble man, Mike.
Inside the raindrop is the reflective surface.
That's the whole point. You need the reflection from the mist and a reflector to go along with
So
it.
are you saying there's another one that's necessary?
I just didn't know that you knew that the ceiling was a reflector. If you know that and you still want to stick with that, then we can carry on. I really didn't want to make the whole debate about that.
Okay, all right.
But this guy's like, yeah, I've read that 10 times. Dude, why would he even say that, dude? I mean,
Because I have. You only need, just water,
show me
sunlight.
your setup, bud. Show me your setup. You just called me out. I showed you my setup. Now show me your setup.
If I have one, I'll show you.
Yeah, he doesn't have one. So here, Brian, look at this one here. I
He
got.
doesn't have one. Everybody listening knows he doesn't have one because he's never fucking done it. We both know that.
Yeah,
I'd like to keep this between me and you, Michael. Now calm down.
So because I don't have one on me right this second, I've never done it in my entire life. Brilliant. That's brilliant deduction right there.
I have a question right here. This is from my friend Joel sent me that.
If you make an indoor setup to try and cast a rainbow, what do you do? Throw it away when you're done? It'd be easy for him to show, but he should have never claimed he ever did an indoor setup to show a rainbow. The point is, and I'll tell you, you can't make a rainbow indoors without a reflective surface or something reflecting. I've tried it several times. It doesn't work, man. That ceiling in his video is clearly reflective. It's, in fact, he doesn't deny that.
Some pictures he took of rainbows. Do you see this here, Brian?
Yeah, I do.
Do you see?
I just got a double rainbow the other day, man. It was cool as fuck.
Did you see a double rainbow all the way?
No, not all the way.
Not
I mean,
all.
it was cool though. It was a clear day. There wasn't even no clouds. It was awesome. Cool.
So here
I couldn't see it all the way because there was houses and shit in the way. I don't know how far down it went.
here's this rainbow here. The rainbow is between him and the trees. If you look, you can see the coloration is affecting the color of the trees. It's between him and the trees. You see that? And
I'm good with all that, man. Hey,
and
believe
it's
it or not,
cloudy.
I've drove through a rainbow, man. I've got my old friends denied it, and I'm like, dude, I drove through one. I mean, it wasn't the colors. I didn't drive through the actual colors, but I was with a buddy, and then my roommate, and we drove through it. And he called me in the middle of the night, like a couple years ago, and he's like, tell these people we drove through a rainbow. And I'm like waking up, and I'm like, yeah, we drove through a fucking rainbow. But it did get bright, and then it got bright for about 30 feet, and then it got dark, and we turned around, and it was behind us. It was cool, but
was
so they
there
say you can't actually catch one?
When you looked back, did you see a leprechaun scurrying away?
No, but there's definitely one in that barn, though, McMichael. But listen, man, my whole point is you're not going to demonstrate one without a reflective surface. Look, Mother Nature is good at making them. I'm not making a dome claim. I mean, to me, that's evidence for a dome, but I'm not going to just jump out and say with just that evidence, yeah, there's certainly a dome. But my point is, you're not going to make one without a reflective surface. And your boy over there, if you can show me that, or if you can, I'd be good with that.
But Brian,
other than that, humble yourself, Michael.
Brian, what if there's cloudy skies and there's no way for the light to get from the mythical dome to?
I never acted like I can imitate and keep up with Mother Nature. My whole point is you're not going to make one with only a water hose. You need a reflector. You can't make one indoors. In other words, you could do it outside in the daytime, but Indoors, you need a reflector. Period. I've tried it. Several times, and you are not going to make one indoors without a reflector. I'm sorry, bro.
Brian, what is the new description for how rainbows work, since this is no longer it?
Okay, just got to go through at least 2 orders. Okay, like a prism. Okay, it's got to go through the one glass, then the other. Okay, or indoors, you need a reflective surface. I'd really like to get past this and start the debate.
All right.
I just wanted to. Yeah.
Let me. Oh dear. Hold on. I got a couple people asking, saying some things here. Let me. So.
Is it fans?
Yeah, people asking some. All right. So let's see. Oh my goodness. There we go. All right, we got Corbin X says Thoth is pronounced tote. H's are silent in Seth, pronounced set. However, this is interpretation, of course, because ancient Egyptian is dead. So I don't know if you missed that, Brian, but I was going to be debating a guy that thinks he's actually Thoth, or Thote, or Tote. David Oliver says he saw 2 rainbows the other day. Very nice. Were they double rainbows all the way? Did you cry, David Oliver? It's okay. You can cry in double rainbows. It's Big K says gives you a participation medal, Brian.
Oh,
That's nice. I'll take it.
David says everything you see has a reflective surface. That's how you see it. It reflects off of the thing you see, unless I suppose if it's the original light source directly from the light source to your eye. Alyssum, do you know Alyssum, Brian? He says, Brian, if you're a doer, come to Australia. I will teach you how to fly and navigate. You won't be a globe denier afterwards. Would you go to Australia to learn how to fly?
Allow me to respond to that, man.
Sure.
If anybody, I mean, I'm sure some of y'all keep up with Globebusters, and we looked at the Google representation of flying from one side of the equator to the other, north to south, and it shows stars coming from the bottom up. Okay, and Iri Landucci just presented a time lapse from a pilot from Zurich to San Pablo from 40. I think it's 42 degrees. No, it's 40 degrees north to 21 degrees south latitude, passed over the equator at a time lapse. And I was wondering why Globers don't use the excuse, because I'm thinking if I was a Glober, I would be like, why can't I see more stars? You know, because if you're going to use, I'll try and make this quick. If you're going to say that we're on a flat Earth, you know, then we should not see more stars as we rise in altitude. That would be like my number one argument. Like, look, if what you're saying is it's a short hallway or limited height, then I would be able to rise up and not see more. And just so happens now I know why y'all don't really use that argument, because in reality that flight did in time lapse just shows the sky just kind of easing off, you know, coming from the going from the top down and then easing off to the right, showing that it's not us moving, and it's the stars moving. It's not what the ISS video shows us. It's not what Google freaking simulation shows. Reality does not match what we are shown. And
having a hard time understanding that.
Love to hear it.
I didn't really understand what you're talking about there at all.
yeah, I have no idea what the hell you're talking about.
Okay, let me try and simplify that. Okay, what we've seen in reality is time lapse from Zurich to San Pablo. Okay, from the northern hemisphere to the southern hemisphere. Time lapse.
San Pablo. Okay.
San Pablo, and so the time lapse plane flight did not show what Google simulations showed or what the ISS shows when you're cruising, and it shows the stars coming up from the bottom. Okay, well the time lapse from the plane did not show that. It did not show that, not even one bit. Anybody who hadn't subscribed to Globebusters, check it out. It was Sunday's little half show.
So I'm still confused. What are you trying to say? You're trying to say that you don't see stars in the airplane?
No, I'm trying to say that there wasn't, you wasn't getting like
The
a
higher
whole.
up you go, the
All right.
less stars you see, right?
But Brian, I don't think you're explaining it well. Maybe it'd be better if people were to watch the
Yeah,
video.
I probably ain't, man. I probably ain't. I'll give you that.
Okay. Go to Australia to learn how to fly, and Alyssa will teach you for free.
Man, I just had my 7th grandbaby, man, and I got some inept children, a few of them anyway. They need me here, man. But I really do appreciate the offer, man. Sincerely.
There you go. He's got a couple yeses, but all right. Ronald Silverfur says light bounces off most surfaces and enters your eyes. That's how we see the world in color. This Flurf has demonstrated he doesn't understand eyes.
Well, give me this, man. Okay, at least until you can show me a rainbow indoors with water, at least until you can demonstrate that, will you give me that so far we see it with a reflective surface, the sprinkles of water plus a reflector? Will you at least give me that until then?
No, because that particular video, the from the light source to where the rainbow was seen, there's no reflective surface between them.
Okay, well, my channel
Whoever said it had to be between them, just make shit up sometimes.
is called Flat Earth Test, and I broke down the reflectors right when I seen the water. The whole Flat Earth argument is you can't make a rainbow indoors without another reflector. So in other words, outdoors, okay, the argument would be is you would need another reflector, not just a water droplets. That's the whole argument.
And like I showed the you're looking, I'm still sharing that to you. That description of how rainbows work inside the droplet of water. I would love to see the hypothesized explanation for how you think this additional reflection is necessary.
Okay, I wouldn't
maybe
say
work on
that would be proof of a dome. I would say that would be like just evidence of a crystalline reflective dome, maybe. I'm not going to 100% subscribe to that, but I would say that Sprite and Elves and, I don't know. I'm not 100% subscriber to that, but I like to
Sprites
I like
and
to keep
Elves?
an open mind. Yeah, you seen the Sprites, where it kind of drops down from the ceiling and shit. But like I said, I'm not going to say that's 100% proof, but I at least use that as at least evidence. But I'm not 100% subscriber to the dome, to be perfectly honest with you. But that's their argument, and I think it stands. It stands inside. You do need a reflector to make a rainbow. I thought you would at least submit to that possibility.
All right. Stringer News 1 is asking, define reflective surface.
Come on, man. Something that reflects, like that ceiling.
I think that was because you were getting confused between refracting, like it does as it enters and exits the water droplet, and reflecting, which is what happens at the backside of the water droplet. So that's, I think, because there's a bit where I think you were, to be fair to you, you were mixing the terms there, and I don't think it was intentional.
Okay, I'll give him that. But hey, man, like you should have took it easy on Latter-day Saints. Like he was being pretty polite and everything, man.
No, he was not. No.
Screw that guy.
Well,
No.
dude, the first three quarters of the debate, I didn't see the end, so maybe something happened at the end that I missed. Okay.
Yep, that's
but
exactly
three quarters,
what
he was
happened.
being okay. But at 3/4 of the way in, you're sitting there saying that 8 inches per mile squared is not how you measure shit, and you know damn good well it matches all the engineering software.
I know
it's just
damn
barely
good well
up
it's
to
the
1,000
wrong
miles.
formula. It's the wrong formula to
Yeah,
predict.
it's the wrong formula. If you want to use L1, L2,
Hold on.
over.
Let me tell you. It's the wrong formula to predict the amount hidden. Where do you put the observer height?
Do a quick Google search right now.
Where do you
Okay,
put the
fair
observer
enough. But
height?
listen, hold on. Yeah, but that's all. That's the only lacking factor. You know what I'm saying?
Then it's the wrong equation.
You know what I'm saying?
You can't use it. It's the wrong equation. Use the right equation. Use the equation that includes.
That's not the way he was making it sound in the debate. In the debate, he was making it sound like 8 inches per mile squared doesn't work for measuring Earth curve. That's the way he's making it sound. That's my point.
Includes the observer's height.
Yeah, well, he didn't catch on. I thought you took advantage of that a little bit, man.
Yeah, if anybody still says 8 inches per mile squared is useful for predicting the amount hidden, they've not been paying attention.
Okay,
The problem isn't.
You're a very good mathematician.
Hold on, I'll say this. I have a problem with the globers that say 8 inches per mile squared is not valid because it's a parabola. That's not why it's an invalid formula. It's an invalid formula because it has no mechanism in the formula, in just that part of the formula, to tell you anything about what is expected to be hidden. So it's always wrong for that. It's never.
It applies perfect to the horizon. That was my point.
Parabola versus sphere. It's always.
I'll
it
give you
doesn't
that.
give you that.
I will give you that. We'll do this real quick. Will you tell me? It doesn't. I mean, at this point, it's not going to be 8 inches per mile squared. We might exceed that. We might not. But will you tell me the expected curvature over 750 miles and of altitude? I mean 7. Blah. Let me say 20 miles in height. What's the expected curvature? Or block?
The expected block. Yep, that's the right term. And I can get you the formula, and we can plug it in. Best to just use it in Walter Bislin's curve calculator because he uses the correct formula there. In fact, on his page, he derives the formula. So I will, right here, I will take a screenshot of this so that people can see it. And I'll show it to you. Maybe you heard the screenshot go. Getting it down here. Come on. Sometimes screenshots take a second. There it is. All right. So, and you're still seeing this. So when I drop it in, you'll see the formula. So there's the formula right there. The second one down would be the one that we want to look at, 8 minus R. Okay, the point is, H is the hidden.
The point is just go to Walter Bislin's.
Absolutely. That uses it. And the other thing is that refraction is a thing. We don't ignore refraction. You know why?
Refraction, which we immediately and adamantly claim is always present, is because there's temperature fluctuation and atmospheric conditions that are consistent.
Refraction also. Yes, I do.
So your model of the flat Earth, fine. I'll tell you how our model works, right? And that's what the formula is. But yeah, let's go to Walter Bislin. It's easy. You just type in Bislin curve calculator. And it'll be the first one, typically. There it is.
Hey, I'm just messing with him about Good Boy, man. Don't take it personal, dude. I'm messing with him, dude.
That Austin Whitsitt, I won't tell him.
No, whoever that was. Was that Austin?
That was Austin Whitsitt. Okay.
Oh, good. I'm glad I said don't take it personal.
All right. So you want miles and feet. So observer height is how many feet?
Okay, let's put it at 127,000 feet. Let's put it at Felix Baumgartner height.
The observer height. Okay. And the target distance.
That's just it. I'm seeing what it says about the target. I'm looking for the distance to the horizon, and I would use like 1.22 times the square height of the 127,000. I would square 127,000 and multiply it times 1.22.
But you need to include.
Would that work?
But you need to include refraction in that, of course.
Well, no, because I got my own refraction. You have your own refraction, and then I'll include mine.
You have your own refraction for your model, your flat Earth model. We have our model, the globe model, that has refraction, and I'll tell you what we would expect to see for the globe.
I understand.
You tell me what you expect to see for flat Earth.
Though. I'm good with that, but give me the geometry, if you don't mind.
The geometry. You want to see a picture of it? There's a picture of it.
I'm talking about. No, give me the geometry before the 7/6 or whatever other refraction.
When you say give me the geometry, what do you mean?
What Walter Bislin says before refracting the viewer or the distance or whatnot, before the 7/6R. Did you hold 4/3? So what do you got?
No, this 001 right there, which is a pretty low refraction.
Yeah, it's 7 divided by 6, right?
No.
I mean, I learned something new. I thought it was 7/6R. I thought that was the K value. Sorry.
So K, to get that particular value, the lapse rate will give you the coefficient 0.17.
So you're not bringing it. You're not talking the lapse rate. You're not going to bring in the lapse rate or nothing. Just
the lapse rate will give you the coefficient of refraction.
Okay. Well, can you give me the geometric answer before K and the lapse rate? Does it offer that?
The non-refracted version. I can put refraction to 0.
Yeah. Please.
So observer height. So the problem is that you don't have an observation of 127,000 feet that we can look at and test. Right. This is
you do. Felix Baumgartner.
Yeah, but did you do any analysis of the distant objects on the horizon to see what you can or cannot see?
I've studied it, but I mean, I can't prove the distance seen, but I would like to see at least what the geometry says, just out of curiosity. And I have a point to bring along with that. You'll probably easily answer it, but I'd just like to at least offer it up.
Okay. What?
You first, man.
I don't know what you're wanting me to. What you're asking.
What's the geometry say for the horizon distance at the distance to the horizon at 127,000 feet?
All right, I will. So to do that, because of the high elevation.
Yeah, no rush, bro. I know, dude. You're good at math, and it might take a second too, but
because of the high elevation, the amount of refraction is very small because the gradient, you're above most of the gradient, so it doesn't change it very much. So if you're...
He's right there at the site, bro. Just give me the damn distance to the horizon, man.
If you're acceptable with a small margin of error, you could use the 1.22 times the observer's height in feet.
And what is that? What is that?
I don't have that one memorized, but this uses... Yeah, this doesn't use the...
He's got a computer right there. All he's got to do is square root the 127,000 on a calculator or whatever, a computer, and multiply it times 1.22. Get on with it.
That's an approximation formula. This uses the actual, the correct, complete trigonometry formula. And the nice thing about it is, he
would say, man, when you get up that high, given a clear day and that the atmosphere is not too opaque, you 700 miles, you think?
I don't know.
Man.
So here you go. Horizon data: distance on surface 435 miles. The dip angle 6 degrees.
So 6-degree dip angle. You look at Felix Baumgartner. I had half a mind to put a clip in right here, but I'm just going to record this and upload it. But go check out Felix Baumgartner. The horizon's exactly the same, when he's sitting still up at altitude. It is at the ground. And they claim it's supposed to be a 6-degree drop. Easily debunkable.
The distance from I, that's, I don't know what the difference on that one is. So 5 miles. So if you were to look at the Felix Baumgartner video and try to analyze and find some distant objects on the horizon, if you saw something significantly more than 435 miles away, then you'd have something. But I've not seen anybody do an analysis of that.
Yeah, so 435 miles would be the globe, and that is without refraction. I will even give you that. But man, I would say that that's not even as far as the let's say toward the tip of Florida, toward Miami, without the Keys, without going off the intercoastal, to like North Florida, and you can see that in a high altitude airplane. I think Jay Toland Media demonstrated that clearly. He could see it good into North Florida, partially into Georgia, coming from close to Lauderdale, which isn't the very bottom of Florida. But then when he got halfway to like toward the end of the panhandle of Florida, he could look back and see the other side of Florida. So that would be my evidence. I would say go check out Jay Tolan Media.
I love Jay Tolan Media. I love cool, his San Jacinto Mountain where there's 6,000 feet hidden behind the curve. I love that one.
You could say that, yeah. I'm good with that, but at least you acknowledge this, MCToon. So you didn't really realize what the horizon's supposed to be until you just did the math and realized that at 127,000 feet, the horizon's supposed to be only 430 miles or 435 miles. When if you don't, you can take away his 1,000-mile observation, but man, can you really take away his 500-mile observation? I mean, it's plain as day seeing the mountains from Texas to Baja California.
Oh,
you really gonna laugh, dude?
He is so terrible at identifying landmarks.
Yeah, I know. Okay, I'll give you that. But is there any other mountains
you got nothing.
Baja from Texas, pal?
Then you got nothing.
I agree with him a lot in this video, just to move things along. But here's the problem: he's not going to show me a mountain closer than Baja California from Texas. Okay, so he's stuck, and he's gonna play it off, but he's stuck, man, and that's 500 miles away. So the closest mountain would be the Rockies, which would be way more than 500 miles. So he's stuck, and he just plays it off.
Oh, is there any other mountains besides Baja close to Texas, MCToon? Tell me a mountain before 500 miles.
Yeah, are you having a seizure?
Stop being a smartass, I will too, dude.
Truck or something over there.
Yeah, should we call the authorities? So do you need help?
Stay there, Brian.
If you stop being a smartass, I will too.
So Brian, let me ask you this: can you see Cuba from Miami?
Don't obfuscate, man. I'm not interested in talking to him. Okay.
So Cuba's only 90 miles away.
Are there any other mountains closer to Dallas than Baja?
Yeah.
Okay.
Mountains.
Yes, there are.
Okay. Then look it up and show me.
It's been done. I didn't.
Yeah, I know it's been done.
He just says it's been done. Yeah, there's mountains closer than Baja California. He just says whatever to fit his argument at the time.
Look up any mountains closer to
Brian,
Dallas than Baja.
Do you know why I haven't looked up that one? Because so many other people have already identified the mountains correctly. So I'm sorry, I don't have it right off the top of my head.
People never thought that at 127,000 feet, the horizon's supposed to be at 435 miles. Why had you do the math?
Now, here's the problem with that. At 127,000 feet, the horizon's 435 miles. Now, what about 25,000 feet where Jay Tolan's at? That's not even nowhere near 100. And that shows you the amount of curvature that's supposed to be there and isn't. So he's giving me numbers at 127,000 feet, and I'm using 25,000 feet height for observations. So he's screwed, man. He's just playing it off.
I don't know why it has anything to do with this, but when they've analyzed his videos, they've found that he misidentified landmarks, and the landmarks that when they were identified properly were completely within the viewable distance. So
yeah, that agrees with my model. Okay, then show me the closest mountains to Dallas, Texas, please.
I don't have that stuff at my fingertips here. So,
all right, fair enough.
You don't either. You don't either.
I mean, you just got me, dude. I don't. You're right, but you just started laughing like it's not even arguable. Come on, man. This is a fair debate, man. Let's keep it. Keep it fucking clean.
I've watched Jay Tolan's, videos, but okay. I
will give you that. I'll give you that. That some of them landmarks are. You could argue that there's something else, but from him to see mountains over Dallas, Baja is technically the closest mountains, and that's over 500 miles. And that one, until you can debunk that one will stand.
Yeah, I'll just go find the video of whoever debunked it already.
Yeah, and once again, that 435 miles is for 127,000 feet. So you see the problem?
Many Karen for 10, I think, shekels says somewhere over the rainbow, Earth is flat. There you go, Brian. You got a fan.
Thanks, Karen.
From Israel. Thanks, Minnie Karen. So here's a good question from Connell Silverfirst. Says Globebusters proved the Earth's rotation with the laser gyroscope, then denied it. They paid a guy to design a mechanical gyroscope. He proved the globe.
That's great, man.
Oopsie.
Then what was the so how did he so he showed 15 degrees. How are you proving that it was the device spinning?
Well, so in science, what you do is you form a hypothesis.